Hello and welcome back. So far we have understood analysis of variance ANOVA on gender and salary, where gender has got only two categories, male and female. If we have more than two categories in the input variable, we should do pairwise ANOVA test as we have done it in chi-square test. So let us try to take another column, the employee brand and salary. Right? Employee brand is the input variable and band is the input variable and the salary is the output variable. We are trying to assess or trying to understand whether employee band has got impact on salary or not. I think you remember, right? We actually try to take different bands, right? Three bands are there. In those three bands, the mean and standard deviations are different or not. If they are different, the features are important. If they are not, the features are not important. Here we will try to see hypothesis testing way. We know the theory, but we will try to look at the hypothesis testing way. So if we try to look at the categorical plot, right, the visualization, there are significant differences, right, between the band A's mean salary and band C's mean salary. But when you look at the C and B's mean salaries, there is kind of little closeness is there. So we cannot say that the employee bands have got clear impact on salary and deciding the salary, because here these two are kind of a little suspicious, right? Even A and B also, the gap is a little less. So let us try to do box plot also. Here it looks like clearly there is difference, and let us try to do the hypothesis testing. So can we use employee band to predict salary? That's what the question we are trying to answer. So hypothesis testing can actually decide that, right? The null hypothesis is that the employee band and the salary are independent. There is no relationship between them. That means employee band cannot decide or cannot predict the salary, right? The alternate hypothesis, it can. Okay. So let us try to see whether it is true or not. The null hypothesis is true or not. How do you say null hypothesis is true or accept null hypothesis? When the p-value is less than 0.05, you reject the null hypothesis. When the p-value is greater than 0.05, you accept the null hypothesis. So let us try to do the pairwise ANOVA test. Okay. So when we look at the count, there are three bands. And each band, A band has got 14, B band has got 10, and C band has got 8. And if you try to look at the mean and standard deviations of each of these bands, right? The means, the first one and second one 10,000 difference, second one and third one is 20,000 difference. But standard deviations of A and B are close when compared to C and others. So kind of it looks like for some groups, the variance is more. Within group and between groups, the variance is more. For some groups, for some pairs, it is less. So let us try to do the OLS test. OLS test is giving a probability value of 0.009. Right? When there are more than 3 categories in the input space, first thing you shouldn't be doing OLS test and trying to take the p-values seriously. Because we need to do pairwise ANOVA and then only we should take the p-value seriously. If we take this seriously, right, we may say we may reject the null hypothesis. That means the band is deciding the salary. In reality, in real-time world, generally different bands will have different salary ranges. Okay, this may be true. But when we do pairwise ANOVA, we will understand what exactly is happening. If we do this, right, we are rejecting the null hypothesis. When we take this p-value seriously and reject the null hypothesis, we may be doing a type 1 error. What is type 1 error? An incorrect decision made to reject the null hypothesis. Okay. So to avoid this confusion, when there are more than 2 categories in the input space, we should be doing pairwise ANOVA. The pairwise ANOVA is ANOVA between group A and group B, group A and group C, and group B and group C, right? So to do that pairwise ANOVA, we can use the multi comparison method, multi-comparison method in stats models, multi-comp module. Right? Internally, when it is doing multi-comparison method, the significance level is going to be adjusted. Okay, this is generally called as post hoc test also, and we are doing a two keys honesty significance difference test, and the adjustment, the p-value, the significance level 0.05 will be adjusted to something else using this formula, where the c is the number of pairwise comparisons, here 3, and alpha is the number of type 1 error, right? The normal type 1 error 0.05. Okay, so if you substitute this, and you will get the adjusted p-value, or the multi-comparison method is actually using this formula to adjust the p-value. Again, as that p-value, it is, it is, that is again as that significance value, the p-value is being compared and then rejected or accepted the null hypothesis, right? Let us execute this and see what happens. So if you see this, the pairwise ANOVA between A and B groups reject false. That means accept the null hypothesis. When you accept null hypothesis, what that means? A and B is, the group A and group B are not so significant in deciding the salary, right? Group A salary and group B salary are not so significantly different. And B and C also the same thing, right? They are not so significant. A and C is significant. When we looked at the bar graph also, we have kind of, explained the same thing. I have kind of explained the same thing. A and C are significant, but when you see A and B and C, there is not much significance. So we cannot reject the null hypothesis and say the employee band is clearly a feature to predict the salary. There is some predictability, there is some predictive power, because the A and C groups have got that difference there, right? But it's not so strongly related to the salary variable. So with the ANOVA test, the pairwise ANOVA test, you will clearly get the picture, rather than doing a OLS test and trying to look at the probability, the p-value, and deciding whether to reject or accept null hypothesis and do a type 1 error or type 2 error. Okay, so that's about the ANOVA. Thank you.